Let's go. Similarity. All right. So in these following two images, we've got a butterfly and we've got some puppy dogs. Okay. What do these items have in common? So what do these items have in common? Who is going to be brave and be the first one to tell me what do these items have in common? So a few people telling us in the chat, okay, size and amount, okay, the size. Some people say translation. They look the same, good. Shape and features, good. They're both the same animal. I like it. All right, so I would agree with you. Okay, they look the same, but they're just different size. So I like that they have a size imbalance. All right. So for these two shapes, okay, in the first ones, I have two butterflies. Those butterflies are identical. Okay, it's almost like I took this tiny butterfly, I went to the photostat machine at your school, okay, and I went and I pressed the enlarge button, and then I copied that butterfly. All right, so it's this shape here, right? I would call the enlargement. Okay, so that would be my enlargement, all right? And this teeny tiny butterfly on the right, I would call the reduction. Okay. All right, if I'm looking at these puppy dogs, all right, I could say that this is the reduced shape, and that this is the enlarged shape. So, two different ways to say it, but it means the exact same thing. Okay, so I have an enlargement, I have a reduction, I have a reduced shape, and I have an enlarged shape. And guys, yes, you write in the chat, my load shedding did just start. So a little bit darker on my face, but still we're concentrating. Lucky my screen's still working, so we're going to pay attention on the screen. Okay. Two objects are called similar if they have the same shape, but possibly different sizes, right? So two objects are called similar if they have the same shape, but possibly different sizes. You can think of similar objects as one being an enlargement or reduction of the other. So guys, this is a really good, okay, a really good time for you to take a nice screenshot. All right, it's a really good time for you to take a screenshot. Okay, some nice little notes there for you. Remember, in the grade 9 exam at the end of the year, right, you're going to be given some multiple choice questions, maybe a match the columns. This is a perfect chance, all right, for you to get 100%, because these are kind of questions that they would ask you in your multiple choice, little theory questions. So go take a screenshot. Make sure you've got that. All right, a little bit of theory there for you. Okay. All right, I hope you've got that image. Let's carry on. If at any time you need me to go back, I'm more than happy to do that. If a polygon is enlarged or reduced, which part changes and which part stays the same? So before we go and talk about that, I just want to draw your attention to this word very quickly as a little bit of a reminder, and that's this word polygon. All right, that's this word polygon. So the word polygon, okay, means a figure with at least 3 straight sides and angles. Okay, so just in case you're wondering, ma'am, what is polygon? A polygon is a figure with at least 3 straight sides and angles. So a polygon can be a triangle, a square, a rectangle, a octagon, a pentagon, a nonagon. All of those fall under polygon. Okay, so if it's enlarged or reduced, which part will change and which part will stay the same? Let's go have a look at the drawing that Ms. Kat gave us. So these are two similar shapes. Okay, this is a triangle that's enlarged, and this is a triangle that has been reduced. All right, so we can definitely see, all right, we can definitely see that what has changed, guys. What has changed? If I had to take my ruler out, all right, what does a ruler measure? What does a ruler measure? Good, the sides. All right. So the ruler measures the sides. All right. So in similar shapes, okay, in similar shapes, the sides will change. Okay. But what will stay the same? What are going to stay the same, whether I enlarge it or whether I reduce it? Good. Well done, Abu. The angles. The angles are going to stay the okay. So the sides will change, but the angles are going to stay the same. The concept of similarity states that two polygons are similar if they have the same shape, but not necessarily the same size. Two polygons are similar if they have the same shape, but not necessarily the same size. In other words, the corresponding angles remain the same, and the corresponding sides are proportional. Now, if you're looking at that and you're thinking, ma'am, I don't understand what you are talking about, right? Those are all words to me, okay? Those are all words to me, and that is not maths, okay? Then I agree with you, that is a lot of words, all right? We're gonna go do some practice, and the more practice you do, the better you're gonna get at it, all right? So let's have a look here at the chat. Doesn't mean they're like in a ratio. Yes, Abu, that is correct. Proportional does mean that they are in a ratio. Well done. Okay. When we look at the next drawing, these are drawings of similar triangles. So there are 3 triangles. They're in different directions, okay? But these are all similar triangles. So if we're looking at it, all right, and if we go do some highlighting here, just to bring it to life, what this drawing is saying to us is it's saying that angle X and angle X and angle X, those are all equal. Okay, so even though those triangles might be flipped in different directions, they might be slightly different sizes, okay, the angles are all the same. All right. Angle Y and angle Y and angle Y are also all the same. Again, even though they're in different directions, or maybe they flipped on their sides, all right, they're all the same size. So if you had to take a protractor and you had to measure them, those angles would be the same. And finally, angle Y and angle Z and angle Z, those are also all the same. Okay, where students sometimes get confused is at this part over here. Right, so sometimes students get confused at this part over here, and it's where you've got this fraction, because I'm not going to disagree with you. At the moment, that to me looks like all letters, letters on top of letters, lines on top of lines. Oh my gosh, ma'am, what are they talking about? I have no idea. Let's go do some of the sums, and let's go see if we can make it make sense. Okay, all right. in our first question, it says to us, what is the missing length? What is the missing length? So what they forgot to tell us here, okay, is that these two sides are actually in proportion. So these two shapes, sorry, are in proportion. All right. So these are two polygons. They've got straight sides. They've got some angles, okay, and they're in proportion. So instead of seeing an X here, I'm going to go make this an X for myself. So there's an X. Okay. Now, grade 9s, I like to use color when I'm doing maths. It just makes everything come a little bit more to life for me. All right. So here we go. I'm going to go pick up some highlighters. If you've got some colored pencil crayons, or if you've got some pens, or if you've got highlighters, that's really helpful as well. All right. Otherwise, even if you have a red pen, not really a red pen, but like a green pen and a blue pen and a black pen, even that can help you in a test. Okay. Stick away from red pen because your teacher will get really angry if you use a red pen. Let's be honest. All right. So here is my X. Okay. And if I'm looking at my drawing, I don't want to start with my X. I want to start at the bottom of my drawing. So I'm going to go match up my sides. So here's the bottom. And there's the bottom. Okay. My next sides I'm going to go match up in green. There's the side. And there's the side. And my last two sides is the X. And so it'll be with this side over here. All right. Just because they've given me so many sides doesn't mean I have to go use all of the sides. All right. I'm going to go and choose to use the following. Okay. I'm going to go choose to use the green sides, and I'm going to do it to find my missing X. Okay. So I'm going to take my, where can we write this? Let's write them on the side here. So I'm going to say X. Let's do this first and get rid of this line so you can't see them very quickly. Sorry, guys, just so I've got more space. Go. Okay. So, okay. So we're going to say X over. Now, I'm going to match up the colors. So there's my X. Okay. And I'm going to put him over my other blue. What's my other blue going to be? He's going to be 15. And if sides are in proportion, it means that I'm going to say equals. I'm going to take my greens now. So my green is 30 over, what's my other green? It's 18. Okay. I want to get rid of the fraction, guys. I want to get rid of the fraction. So to get rid of the fraction, I'm going to take this 18 and I'm going to multiply on that side. Okay, so 18 times by x gives me 18x, which is equal to, and I want to take this 15 and I want to multiply him that side. 15 times by 30 gives me 450. Okay. Hopefully we're all good. All right. Divide both sides by 18 to get rid of the 18 in front of the x. And I'm left with x is equal to, who can tell me, what's 450 divided by 18, guys? What's 450 divided by 18? Benjamin's got it. Who else? Who else has got a calculator on them tonight? Quasi, good. Well done. Well done, guys. It's equal to 25. All right. So that's if I use the blue and the green. Now, some people are saying to me, ma'am, where did the 35 go? What about the yellow, ma'am? Why haven't you used the yellow? So I'm going to go show you what happens if I use the yellow instead of using the green. So what happens if I use the yellow instead of the green? Okay, so here we go. So I don't have to show both. I don't have to show both. I can only show one, but I'm going to go show you what happens if I use the yellow instead. So again, I'm going to have X over, and I'm going to put it over the 15, hey? Equals. Now I'm going to go take the yellows. I'm going to go take the yellows, okay? So I'm going to have 35 over, the other yellow is 21. Now I'm going to go cross multiply. All right. So 21 times by X gives me 21X. 15 times 35. What's 15 times 35, please? What's 15 times 35, guys? 15 times 35, 525. Thank you. Right, divide both sides by 21. X will give me 25. And somebody in the chat did tell me, well done. I should have written here as well, units. If I don't write units, what's going to happen? I'm going to lose my mark, eh? So well done. Good. Okay, so you get the same answer. All right, maths is beautiful. Oh, I love maths. So beautiful. All right. Okay, so that is how you do proportion. Right. Let's have a look at the next question. Oh, hold on a second. Anyone who wants to take a screenshot? Anyone who wants to take a screenshot? I'm going to give you 2 seconds. 2 seconds, very quickly. Okay, right. Ma'am, how are they similar if they don't have a constant multiplier? So they are similar because they do actually have a constant throughout, all right? They don't have a constant multiplier, but they will have a constant throughout their fractions, all right? But you don't need to know that in grade 9. Okay, let's move along. So in the next question, it says, show why the following shapes are similar. So in this one, they want us to show why these shapes are similar now. All right. I like this question. Okay, it gets asked a lot. All right, it really does get asked a lot. And there's a really nice standard way for you to answer it. That's why I love doing these kind of questions. Okay, so let's go have a look. All right. So when we answer this, we're going to do the following standard answer. We're going to say, oh, I'm out of space. Okay, guys, what I'm going to do, because I'm running out of space, is I'm going to go and put this on the next page for you. So give me 2 seconds while I go and take it to a new page, just because I'm running out of space and I don't want to squash it around because it's such an important thing for you to learn. Okay, so let's take that picture and let's put it in there for you. All right, so there's my drawing. Okay, and I want to do our standard answer here. All right, so if you've done congruency before, then you know there's a standard way to do congruency. There's also a standard way to do similarity, and here it is. So we say, in triangle A, B, C, and triangle D, E, F. Okay, so I always say to everybody, when you're doing congruency and similarity and when you're proving it, right, how many sides are there in a triangle? There's 3. How many angles in there in the triangle? There's 3. How many reasons do you need? You need 3. Here we go. Number 1. We know that angle A is equal to angle D, which is equal to 45 degrees. Did I have to calculate that? Did I have to go search for it? Did I have to go climb a mountain for it? No. What happened? It was given. Number 2, angle B is equal to angle E, which is equal to 55 degrees. Again, climb a mountain, go look for it, do any of those things? No. It was given. Number 3, angle C is equal to angle F. Now, in the last class, okay, you can either go and say, all right, equals 80 degrees, all right, angle some triangle, or angles in the triangle equal 180, or whatever it is that your teachers have taught you, okay, or you can say remaining angles in the triangle, or whatever it is that you calculated at school, all right, or all right, you can go and calculate that angle and then say that it's equal to 80 degrees. It's the same thing, guys. It's the same thing, okay? All right, therefore, triangle ABC is similar to triangle DEF. Reason, angle, angle, angle. Okay. All right, somebody's asking me, ma'am, is it wrong to say interior angles of a triangle? Yeah, that's not one of the reasons, unfortunately, interior angles of a triangle. So you won't get a mark for that one. Okay. Somebody else was asking me, ma'am, can you not, where was it? Somebody was saying, why not CAD and FDE? And I see Miss Simone did answer that question. So we can just use the capital letters here because there aren't any other naming angles here. So it is okay for us to just use that. All right. Now, guys, because these triangles are similar, it means that the sides are in proportion. And I want to show you a quick cheat way to show that those sides are in proportion. So I use froggy face here, okay? I'm going to show you how to do froggy face. All right, so to show which sides are in proportion, this is an easy way to do it. We're going to say AB over DE is going to be equal to BC over EF, which is going to be equal to AC over DF. All right, gives us a little froggy face. The reason why those are in proportion, because triangle ABC is similar to triangle DEF. So the way that they name the triangles helps you to know which sides are in proportion. Okay, and you can draw a little froggy face, all right? It might seem silly now. Your friends might laugh at you when you're in class and you're drawing a froggy face in class, all right? But trust me, when you're writing your test and your exam and you're getting full marks, I'm going to be laughing at you anymore. Okay, all right, froggy face will help. Okay. All right, hopefully you've got that. If you haven't got it written down, take a screenshot as well, but I will give you a minute or two to finish that off. Okay. All right, I see one or two people still writing, Miss Simone, and don't know about you. We've got some really hard workers tonight.
We always have such hard workers in our classes. They make us so proud.
All right, guys. Okay, if you do need me to come back to the screen, I'm more than happy to do so, okay? Just let me know at the end of the lesson. We're going to move on to the next question, and we can always come back if you do need to come back to this question. All right. So let's have a look at where we were before we ran out of space. Oh my goodness. Oh, that's a lot of figures. Whew. Let's see. That looks like two trapeziums to me. I don't know about you. They kind of look like a trapezium. Four-sided figures. I've got some numbers there. I've got some angles. Okay, and then I've got a dot, it looks like. All right. And what is the question asking us, guys? So I'm assuming that it's wanting us to find out what this this missing side is here. Let's see. Show why the following shapes are similar. Okay. I'm thinking that that's what it wants us to do. All right. So I'm thinking it wants us to show why those shapes are similar. Okay. All right, let's go have a look. Again, let's see how much space we've got from this cat. Oh, we've got quite a bit of space for this one. All right, so for shapes to be similar, okay, all the angles need to be equal and the sides need to be in proportion. All right, so let's go have a look at how this is going to work. I think the first thing, which might be the easiest thing to do, is to prove that all the sides are the same. That might be the first part of it. Now remember, there's two parts here. The angles need to be equal, and then the second part is that the sides need to be in proportion. So step one, we're going to look at the, okay, we're going to look at the angles. So step one, we're going to look at the angles. Okay, so in D, E, F, G, and H, I, J, K, number one. Angle D is equal to angle H, which is equal to 105 degrees. Reason given. Okay. Number two. All right. Angle G is equal to angle K, which is equal to 100 degrees. Reason given. Number three. Well, this is a lot easier than I thought. Angle F equals angle J equals 80 degrees given. This is really easy, guys. Hey, well done. All right. Number four, angle E is going to be equal to angle I, which is going to be equal to, guys, what's angle E and angle I going to be equal to? What's angle E and angle I going to be equal to? What are the angles inside of a quad add up to? Careful, don't let them trick you. What are the angles in a quad add up to, guys? They add up to 360, good. All right, you are completely right. Normally for similarity, it's only 3 reasons, but now we have a quadrilateral. You are right. Because remember what I said earlier, for triangle, 3 sides, 3 angles, 3 reasons. Now it's a quadrilateral. Quadrilateral, 4 sides, 4 angles. How many reasons? 4. Good. So these need to add up to 75 degrees. Reason, angles in a quad. Therefore, DEFG is similar to HIJK. Reason, angle, 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 angle. So all the angles are equal. Okay. All right. Because all the angles are equal, we know that the sides are similar. Okay, we know that the sides are similar, but could we also use it to prove similarity? We could use it to prove similarity. Okay, we could go and use it to prove similarity, but we could also then go and say that, therefore, okay, DE over HI, and this is going to be a really weird froggy, so forgive this looking froggy. It's going to have, look like he's from a chemical spill here. So DE over HI is going to be equal to EF over IJ, which is going to be equal to FG over JK, which will be equal to DG over HK. These froggies have 3 eyes. Okay. All right. Hey guys, what's the reason for this? The reason for this is because DEFG is similar to HIJ. Okay. All right, moving on. You guys are doing so well. Well done. Oh my. Let's have a look at another one underneath here. That's very similar to the last one we did. Okay, this next one says, the following shapes are similar. So I want you guys to try this one by yourself. I want you guys to try this one by yourself while I answer some of the questions that have been asked, okay? I'm going to let you guys have some time to try this by yourself. I'm going to give you 2 minutes while you're trying it by yourself. All right, so let's have a look. Okay, it says, are we still going to have maths class in December holidays? Guys, no, there's no maths classes in December holidays. Our last classes are in November, just like Miss Simone said. All right. Do we have class in September holidays? We are having some boot camps coming up. So just like we did on the last lot of holidays, yes, we have some fantastic classes planned for you guys in September. And then don't forget, you guys have exam prep coming up. Guys, we have some exam prep classes coming up. So make sure that you get the adverts for those. Make sure you sign up for them early because we all know how quickly those classes fill up. Hey, Miss Simone? They fill up super quick. So make sure that you sign up for exam prep classes. Okay, I see some people are answering the question already. Ma'am, what happens when you are just given the measurements for the sizes and not the angles? Well, for these ones, they've told us that the shapes are already similar. So we don't have to prove that they are similar. We're trying to calculate X and we're trying to calculate Y. That's what we're looking for. Okay. All right, some people are trying to give me the answers already. Okay. All right, 1 more minute, and then I'm going to go and do it. 1 more minute. Oh, Miss Simone, it looks like I've got somebody in the picture who looks like they're sleeping. Oh, no, they're moving. Okay, they're awake. All right. I was hoping I hadn't put them to sleep, that's all. I think maybe it's because it's so dark in the background. Oh, Abu, do we have to register at Watobe again next year? Miss Simone, I'm not sure if you can answer that one. Do you know if they have to register if they're already registered?
I am not sure, but I can ask and I will get back to you on Thursday, Abu.
There we go, Abu. Oh, what would we do without Miss Simone? All right. So, guys, they have told us that these shapes are similar. Okay, and they've asked us to calculate X and Y. Now, normally what they would have done is they would have said this. They would have said in the drawing, okay, they would have said triangle ABC is similar to triangle DEF, and then they would have said calculate X and Y. So you would have needed to go and you would have drawn your froggy face. That would have really helped, hey, froggy face. So you would have gone AB, DE, BC, EF. So AB over DE equals EF over, oh, sorry, BC, what am I doing? Over EF, okay, equals AB, AC, whoopsie, over DF. Okay, so that's your froggy face, hey? So you would have gone, you would have drawn your froggy face, okay, and those would have been your sides that are in proportion. Now, let's go see the sides that you actually need. So the sides that you need are as follows, all right? So you're looking for BC. So BC is this one over here. Okay, so that's the one that you're looking for, right? You've got every other side, right? If I'm doing it with 3, guys, it's super confusing doing it with 3. So I wouldn't do it with 3. I would choose to just use 2. So I'm going to look at using this one and using this one. So I'm going to go say, okay, instead of writing AB, I'm going to say 5 over, instead of writing DE, I'm going to go say 10 is equal to, instead of saying BC, I'm going to say X. Instead of writing EF, I'm going to say 16. All right, I'm running out of space. I'm going to come here. Okay, I'm going to cross multiply. X times by 10 gives me 10x. 5 times by 16 gives me 80. Divide both sides by 10. X is equal to 8. So well done to those of you who said that it was equal to 8. You are completely right. Okay. For those of you who are asking, ma'am, where's Y? There's Y. All right. Have a look at that one. All right, let's go have a look. So those two shapes are similar. So again, I'm going to jump ahead a little bit for us. I'm going to go say, well, I know that QP over DE is going to be equal to PR over DF. How do I know that? Because the sides are similar, so they're in proportion. So QP equals 9, DE equals 3, PR equals 6, and DF equals Y. So 9 times by Y gives me 9Y. 3 times by 6 gives me 18. Divide both sides by 9, and Y will give me 2 centimeters. Okay, guys, I am running out of electricity and light from outside very quickly. So somebody did ask me, ma'am, can you please go back to the previous question? I'm trying to see, ma'am, can you go back to the previous activity at the end of the lesson? Kwezi, I'm not sure which one you want me to go back to, but of course I can go back to whichever one you want me to go back to. That's fine. Somebody's asking me, ma'am, no brain break. Guys, I was very clear about brain break at the beginning of the lesson. Okay, Kwezi, if you just tell me which exercise you want me to go back to, that is not a problem at all. Miss Simone is going to put up your poll for this evening. Grade 9s, I would like every single person who is in this class to make sure that they answer the poll for Miss Simone, please. Every single one of you. There are 121 people here. 121 people need to answer that poll, please. Okay, while Miss Simone's doing that, you have asked me to go up to the very first activity. Of course, I can do that for you. All right, so up to the very first activity for you to start answering questions. I see, Kwezi, you have your hand up. Kwezi, can I answer a question for you? Quizzy? Quizzy, you should be able to unmute yourself. Oh, grade 9s, only 83 people. There are 121 people in class. Okay, Quizzy, if you should be able to. Could you have simplified the 9/3 further? Quizzy's asking me. I think, Quizzy, you asking me about the last question. So Quizzy, in this question, what do? We don't want to simplify this further. What do? We're going to cross multiply to get rid of it. But I suppose you could, if you wanted to, you could say 9/3 gives you 3, and then 3 times y, and then divide that. You could do it that way, I suppose, yes, but this is the easier way to do it.